Okay, we're going to analyze a polynomial, but instead of given an equation or a graph, we're just given a table of points. So what could you do with these points? You could graph them on graph paper, right? And when you did that on graph paper, then you could connect them to see what the polynomial looks like. But we really need to be able to analyze a polynomial just based on a table of values, and I'm going to show you that here in this example. So because it's a polynomial, just by underlining that fact, we do know that it is a continuous function. Continuous means there's no holes, there's no breaks, continuous. So even though it only gives us some of the points, a polynomial will look like a string of spaghetti. I'm actually making spaghetti tonight for dinner. What a coincidence. So, do you ever skip the instructions and just get right to it? I do that sometimes when I'm building something at home. But these instructions have a bunch of clues, so we need to make sure we read them. So the polynomial tells us that it's a continuous function. The zeros in the table are the only zeros of the function. So it crosses the x-axis here and here, and then there's no more. So there's only 2 times, only crosses the x-axis twice. And no zeros have a multiplicity greater than 2. So these zeros, they could have a multiplicity of 1 or a multiplicity of 2, but not 3. Okay? Ready to answer some questions? Identify the left and right end behavior of the function capital F of x. So here's the left behavior. As x approaches negative infinity, where is the y value going? Do you see how the x values are listed in order from least to greatest? Do you see that? So if you look all the way to the left, look at the left of the table, this is negative 147. So if you were to plot that point, well, sorry, look over here. Do you see how it goes from negative 10 to negative 147? So these y values, are these y values going up with an arrow up, or are they going down with the arrow down? So they're going down, so the left end behavior is negative infinity because that's a large negative number. So if we want to start our graph here, we know at negative 6, the graph is pointing down because of the negative y value. It goes from negative 10 to negative 147. So we know it's decrease. Sorry, it's not decreasing. It's hard to go backwards, right? So I think you know what I mean, so I'm going to stop using the wrong words. Let's look at the right. As x goes to positive infinity, so start in the middle of the table and go to the right. X is getting bigger. 6 isn't really close to infinity, but it's getting there. Okay, we're going to the right. Where is this y value going? So we were at a y value of 1, and then we jump up to 225. So this y value is going up, positive. So how do we say that here? As x approaches positive infinity, f of x approaches also positive infinity. Do you have this picture? Because look here. Based on the end behavior, that's what we just drew. Based on the end behavior, what must be true about the degree of the function? Do you know what degree means? Because maybe we haven't said it enough. The degree is the exponent or power exponent. What's the difference between an exponent and a power? Look it up. I want you to learn what that means. So is the degree of the function, what must be true about the degree? Okay, are these going in the same direction or different directions? They're going in different directions. So the degree must be what, even or odd? If they're going in different directions, the degree must be odd. And what else is it asking us? About the sign. Sign in math means positive or negative. The sign of the leading coefficient. So the leading in front, the number in front, is it going to be positive or negative? And do you know why? Based on the end behavior, based on these arrows, is this going from down to up. If it's going from down to up, then the sign of the leading coefficient is what? Positive. Degree must be odd, and oh, it says give a reason. I'm going to erase for a minute if I can find my whiteout. Here we go. Degree must be odd because arrows are in different directions. Arrows point in different directions. And is the degree, what did we say? Sorry, we said the degree is odd, positive or negative in front. It's positive because the arrows go from down to up. Arrows, I'm still here, go from down to up. Do you know what that means? Increasing. So the sign of the leading coefficient is positive. Positive. There you go. Okay. Identify the zeros and the multiplicity of each zero of f of x. Justify your answer. Ready? What is the x value when the y value is 0? So here's the y values on the bottom row. F of x, this means y. So not 0, not 0, 0. This is a 0. So the x value is -3. Now what the heck? How could we tell the multiplicity? You have to look on either side of the 0. It's either going to be a 1 or a 2. Remember? That's what the question told us. So if it's a 1, then it's going to cross from the negatives to the positives or from the positives to the negatives. If it's a multiplicity of 2, it will bounce, which means it will be negative, hit the 0, stay negative, or positive, hit the 0, stay positive. So you tell me. Sorry, the lights are adjusting. Hold on. Okay, here's our 0. X is -3, y is 0. This goes from negative, which is below, to positive, which is above. So if you go from below the x-axis to above the x-axis, did you cross or did you bounce? We crossed, so it's a multiplicity of 1. Y values change from F-R-O-M-E from we're going to say, I don't have enough room, so from negative to positive, meaning that it's a, quote, it's a cross. It crossed the x-axis. What's the other 0? The other 0 is here. Do you see the number 0? That's a 0. What's the x value of that 0? 1. Okay. Now, was that a bounce or a cross? Sorry for the lighting changes. What's on the left of the 0? Is this positive or negative? Positive. And what's on the right? Positive. So if it stayed positive, then that means it's a bounce. And so the multiplicity is 2. And I'm going to write the reasons here. Y values on either side are positive. So the function, what is it called? F of x. You can't say it. You have to name it. Say my name. You have to say the name. So f of x bounced, B-O-U-N-C-E-D, bounced off of the 0. All right, you're going to try this one. These are just quick little notes. You're going to try this one, but let me talk you through it a little bit. So we're going to look at the number on the left. Do you see that y value is going, is that positive or negative? Positive. So the end behavior on the left would be going up. And is this positive or negative? It's positive. So the end behavior on the right would be going up. So that's left and right end behavior. Are these the only zeros? How many zeros are there? 1, 2, 3. The zeros in the table are the only zeros. Okay. No zeros have a multiplicity greater than 2. If this goes from positive to positive, then this is a bounce, and this would have a multiplicity of 2. This goes from positive to negative, which means it didn't bounce, it crossed. It went through the x-axis. And this goes from negative to positive, so it crossed back. So multiplicity of 2 plus 1 plus 1 means the degree is, what's 2 plus 1 plus 1? That's the degree of 4. And that matches our end behavior here. Okay, so you're going to answer these. I want you to try it on your own and we'll check them in class.